Hi, and welcome to the first in a series of videos that I'm going to be doing along with Mark Waite. Mark, how are you doing?
Hi, Darren.
So, just in case you don't know who we are, my name is Darren Pope. Again, I've already said this is Mark Waite, and we both work at CloudBees. Can I say that 5 times fast? No. And leading up to DevOps World on Tuesdays at noon Eastern at 9 a.m. Pacific, and whatever else the math is for you, because I can't do date math for all 24 time zones. And actually, there's more than 24 time zones.
There are quite a bit more than 24. Don't get me started on that one.
Anyway, we're not talking about time zones today, but we're talking about something probably just as obtuse, and that's Git for large repositories. I mean, come on, Mark. Large repositories? What is a large repository?
Yeah, so a large repository, when I think of it in the world of Git, is something bigger than, say, 500 kilobytes if you compute the, or 500 megabytes. Kilobytes,
okay.
Megabytes. Sorry,
okay.
Megabytes.
Keep going.
Bad number, yeah. Something bigger than 500 meg is really in the realm of large repository. Now, if you're even at 100 meg, you should be wondering why you're that big. But most people, by the time they cross that 100 meg threshold, are already well on their way to really scary sizes. So some examples: the Linux kernel, actively developed, maintained in Git, lots and lots of source code, over 2 gigabytes. Other repositories I've maintained in the past hung my head in shame when the repository reached the size of 20 gigabytes. Those things can be huge and really unwieldy to manage and maintain. So today's session is to help people understand that you may not be thrilled with the condition you have right now, that you've got some large repository, but it's probably not easily avoidable for you to shrink the size of that repository. And therefore, let's find ways and discuss ways that you can manage that large repository a little better in the Jenkins environment.
Yeah, when you said 500K, it's like, I would love for that to be large.
Yeah, sorry.
But no, it's okay. 500 meg. 500 meg seems insane to me. That's not large. That's like super large.
Well, and see, it depends on your perspective, right? Because, for instance, the Jenkins.io website, with all of its images and the pictures that are on it and all of the content there and all of its history, is still only like 100 or 120 meg. And so 500 is really large. But my point there is that as you get into these large spaces, whether it's 100 meg or 500 meg or a gig, starts to be less and less important, and more important is the fact that, I need to do something to manage the size of this behemoth. So
how do we do that?
Okay, well, so
do you want to show us, or do you want to talk about it some?
I wanted to spend some time first talking about why this is different than some other places first. Mm-hmm. So Git, as a distributed version control system, manages all the history in the local repository. It's got everything there. That's really powerful. It means operations like diffs, logs, comparisons, those kind of things are all local operations on the file system, and thus very, very fast. That was one of the reasons Linus created it that way. But it also means that all of that history has to be copied locally. Other version control systems and predecessor version control systems before disk drives were so cheap did things differently. Subversion, CVS, ClearCase, Perforce, all tend to use a model where large chunks of the content are kept on a central server, and you may need to ask questions to the network in order to perform differences, to generate full depth logs, etc. And Git is different that way. It stores all of its history locally. And by storing all of its history locally, you get fast, but you also get big if you choose to put big inside that repository. And that big stays with you forever. So if I checked in a 100 megabyte file 5 years ago, that 100 megabyte file is still there, even if I did a git rm later to remove it.
That's strange.
It's
I know why, but it's
right.
Strange.
Well, and it's hey, there are solutions for that, right? I can actually mutate the history of the Git repository, but most of us intentionally choose not to mutate the history of the Git repository because it really complicates the life of others who are interacting with that Git repository. So yes, I could go and take that out. There are ways to shrink the size of my repository, but most often, particularly in a larger organization, if you're working with more than 2 or 3 people, you may not be able to adequately coordinate the work that's necessary to shrink the size of a Git repository once it's grown to a large size.
I could step on something. I'm going to go ahead and say it, and we can weave it in later. Monorepos. So that's all I'm going to say right now. We'll just let that sit.
Well, and monorepos, there's a good example of that. Let's take one.
Okay.
The Linux kernel.
Wait.
Call a monorepo.
Ooh.
Come on, that thing.
Okay.
That thing
All right.
manages.
I'll give you that.
That thing manages an enormous set of code, right? With many different things, drivers for all sorts of things, components for this and for that, schedulers. It's huge, and it's 2 gig. So if you're building Linux kernels, maybe you're an embedded systems developer, or you're doing something that really needs your work inside the kernel, and you're using Jenkins as your CI server, you're going to be dealing with a 2 gigabyte repository that you have to get onto the Jenkins controller for pipeline work, and you have to get it onto agents to do work on agents. And a 2 gig repository is a non-trivial thing.
We have this thing called speed of light.
Right. Physics matters. It's not just a good idea, it's the law. Yes.
Even if you have a 10 gig pipe, well, actually at 10 gig, it would start making sense a little bit. But you're still moving files around in chunks.
Right.
And it's still, even if you've got SSD, it's still going out on pages.
Right. There are all sorts of interesting challenges that go with moving this much data around and to many different places, right? We have all sorts of interesting challenges there. Yeah. So the problem is real. And what we want to spend some time today is talking about what options are available to help reduce the impact of the problem on you as a Jenkins administrator or you as a Jenkins user.
Or maybe just you as a Git user.
Right, exactly. Well, and good point. Yes, because I, as a Git user, use some of these same techniques very, very effectively to make my job faster when I'm working on things. Good point. Okay. Let's talk to that.
All right. So what's up next?
Okay, so let's first talk about, there are 3 places where we see this kind of issue. Area number 1 is on the central repository. All right, so a 2 gigabyte repository, when we store it on the central location at github.com or my local Git server or on a Gitty server or on a Bitbucket server, it's going to occupy some space, and it's going to need some thought, and it's going to occupy some processing capacity whenever we ask questions about the contents of that repository. So we've got to think about impact on the centralized server of the Git repository. Then we've got to think about the impact on the Jenkins controller that's sort of in the middle of it all, because the Jenkins controller, when it's doing pipeline work, will grab a copy of the repository, or may grab a copy of the repository. Again, this is a place where you can optimize things, and needs that to get the pipeline files. Then we've got the third location, and this is probably the biggest data volume, which is out on the agents. So every time you start an agent, and that could be ephemeral agents, it could be static agents.
So let me ask this. When a job starts, a pipeline job starts, let's be explicit, the clone goes to the controller.
Well, and now there's already a subtlety here. Right?
Right.
And this is an important, first step. You've already taken us into a very good first step.
Okay.
Certain providers, like the Git provider, don't know about REST API calls to the hosting service. So the Git provider, for instance, doesn't know that GitHub has a separate REST API that could get the Jenkins file for us. And it doesn't know that Bitbucket has a separate REST API, or that Gitty has a separate REST API. And because of its not knowing that, it does the simplest thing that could possibly work and clones the whole repository. Unfortunately, with large repositories, that's expensive. So given a large repository and one of the common hosting providers, your first choice with Jenkins pipeline is be sure you use the SCM provider that is closest to your Git provider. If you're using GitHub, use the GitHub SCM, not the Git SCM for your pipeline. If you're using the Bitbucket SCM, use the Bitbucket provider. So, Darren, any questions there?
No, that makes sense. So now let's assume that let's assume worst. Let's assume that I use the Git provider.
Mm-hmm.
So it clones to the controller.
Right.
And now I've got a properly formed Jenkins file that has an agent defined in it.
Right.
And I have that agent connected to my controller. Is my agent then cloning? Or am I going to be pumping everything across the wire to the agent that I've already cloned?
So the good question on the directionality of data transfer, right? So what happens then is controller asks the central provider, give me the repository. Gets the repository. Controller then tells the agent, begin executing your pipeline. The agent in the pipeline has a step, says check out SCM, or if they're declarative, it's actually implicit. In declarative pipeline, it will do this implicit checkout SCM, and it then requests the data from the Git provider, not from the Jenkins controller. Now, that's usually actually a very healthy thing because we want the benefit of parallel requests going into the Git provider without channeling them all through the relatively thin connection between the controller and the agent. We don't want to overload the agent to controller by shipping a bunch of Git data that we can request in parallel from the Git provider directly.
Okay, so let's put that one behind us.
Mm-hmm.
So if I'm using a specific provider, GitHub, Bitbucket, Gitty, and the controller would make that Gitty call, but then what happens once I get down to the agent then?
It will then clone the entire repository.
Going all the way down, basically just using the Git provider under the hood, correct?
Correct. That's correct.
Okay.
And that makes sense because the job, in the job context, it is initially working on the assumption that you need the entire repository. And one of the optimizations we can make is when we know more about our specific job, we can know, I don't actually need I don't need the full depth of history, or I don't need every branch on this particular checkout. Most multi-branch pipelines, for example, are really interested in testing exactly one branch. And so all I need to do is request the data for that branch. I don't care about the other data. And by narrowing which set of data I request, I can reduce the demands on the Git server, reduce the data transfer demand, and reduce the local data storage demand.
So with multi-branch, if you were to look at the console log, you would magically see that when it's doing the Git fetch, right? Because you see that branch specification. Is that true or not true?
It depends, right? Because there's the complexity here is sometimes the choice is made to, so the thing that Darren and I are now discussing is a thing that Git calls the Refspec. A Refspec is a definition of which branches or subsets of the remote repository should be mapped to things on the local repository. And this Refspec concept is that by default, the Refspec says, give me everything on the remote, copy it local. So a clone pulls everything. However, in multi-branch pipeline, we can gain we may be able to gain some significant benefits by saying, hey, only give me the branch that I'm working on. Now, I have to openly acknowledge there are some places where this thing backfires, right? Where you may say, I thought I only needed one branch, but as it turns out, I'm the maintainer of the Git plugin, and I have tests that depend on multiple branches being available in that repository. So the reality is you need to know something about your environment before you make the decision that you only want to clone exactly one branch.
Okay, let's get away from the sadness of that for a moment. So you brought up Refspec, which is cool. So now you're starting to get into the weeds. How many more other sort of top level? Because really, Refspec is a top level weed.
Refspec is a very top level read, right? It's a very high value, potentially very high impact. So as an example, in terms of Refspec, I have a repository that's 160 megabytes of data that I use to do Jenkins bug verification. Is this bug still fixed? Is this bug still fixed? And I have one branch per bug, which means in this large repository, and each of those branches is largely independent, I can dramatically reduce the data transfer by choosing to only work on one branch at a time. And because they're independent, it works really, really well. So Refspec is a top-level thing. Now, there's another top-level thing we should discuss. So, Darren, let's you and I take the next top-level item. So the next top-level item is a reference repository. So one of the things that Git is very smart about is...
Time out.
Oh, go ahead. Yes.
You consider reference repositories sort of top-level and not way down in the weeds?
I do consider reference... Well, when I say top level, let's test this because maybe you and I have different definitions of top level.
I think we do.
Okay, so for me, top level means potentially enormously high impact and very, very positive results.
Yeah, no, that's not what I'm thinking.
Okay, so
I'm just thinking. I'm thinking low hanging.
So
top level for me is basically the just beyond low hanging fruit, right? Just beyond that, right? So what is that next little? I had to get the step ladder out. I couldn't get it right from the ground.
Got it. Okay. So,
but I didn't have to go get the cherry picker to go do the next thing. So to me, reference repositories are a cherry picker type. Not to confuse cherry pick with cherry picker, but hey, yeah, that's what it is. But let's continue on. So reference repositories are insanely confusing to me.
Oh, okay. Well, so this will be a fun exercise because let's go back a little to Refspecs. Refspecs are easy for the user because all they have to do is configure them in the job definition. It's a very simple thing for the user. It doesn't have makes no demands on the agent, makes no specific demands on the controller. I configure the Refspec and I'm done with the task. So in that case, Refspecs are really, really elegant. Reference repositories are different. And now, Darren, let's go back to your question on, hey, what's confusing about reference repositories? So share with the audience some of the things you found that are confusing or complex about reference repositories.
Well, that means I have to have it on disk. I have to know where it is all the time.
Right. Exactly.
And that's not always possible. Or excuse me, it is possible, but now I'm locked into a single point of failure-ish, right? Because I could always rebuild that reference repository. I could do that, right? Mm-hmm. But the problem is if this is a large and I've got a really bad network and I've got really slow disks, that's going to impact me getting anything done, Jenkins or not. Right?
Correct.
That's just a bad thing if I ever have to refresh a reference repository.
Well, and let's take that concept. So what you just highlighted is that a reference repository has to exist in the context where it's going to be referenced. Now, that may sound really obvious to people, but by stating that a reference repository must exist in the context where it will be referenced, that means my ephemeral agents need to already have the reference repository on them. Well, wait a sec. I said ephemeral, and then I talked about a large chunk of state. That's sort of contrary to the notion of an ephemeral agent. Most ephemeral agents, we want not to have an awful lot of stuff in their disks. So reference repositories makes that complicated.
Beyond complicated. I'll put it that way. Just beyond complicated.
Yeah, well,
But the upside. Mm-hmm. But the upside. Well, go ahead and finish your thought. Because
it means we have to think about a way to fill that, pre-fill that ephemeral agent with content. And that's more complicated. It either means build a Docker container that has it in it, or it means use a network share that has it, or do some other thing, and all sorts of complications that require more thought in order to handle these large repositories.
So, because you have chosen to create a large repository, mm-hmm. you're having to pay this penalty?
Yes.
I was going to say tax, but this is worse than tax. It's a penalty. Right. That you've allowed your Git repository to grow unbounded. Again, if the whole Linux kernel is only 2 gig, that's not that big when I think about Linux kernel. When you were
Right.
talking earlier that you had 20 gig repositories of, okay, what were you thinking?
Right,
So-
and you make a good point, and I think you take us all the way back to the original question. The first question for someone in this situation is there a way that I could stop using a large repository and instead switch to using a smaller repository? Because that avoids all the hard problems and all the questions. And it's a good first question to ask yourself.
And this is still, again, Jenkins or not Jenkins.
Right, right.
Or fill in the blank of anything else. This is just Git.
Right. This is a net developer productivity improvement by reducing the size of your Git repository. If you have made the terrible choice of putting large binaries in your repository, and there are industries where it has to be done, right? They may say, look, I'm building video games. I need to archive a copy of this large movie clip or this bunch of pictures or whatever. But then you need to ask yourself, well, could I store those in a separate way or in a different way? For instance, could I use Git LFS if I want to do them right inside inside Git? Or could I use an artifact repository to host those large binary artifacts with all the benefits that come with artifact repositories, like mirroring and transparency? So it doesn't have to be the simplest solution to store your large binaries. The simple solution is git add monster blob, git commit, git push, wait long time, and then suffer forever. But the better way is git LFS add, or is commit it to a repository and then reference the repository.
Git LFS. We could probably spend a whole nother session just on Git LFS. But
Yes,
we're
yeah.
not going to do that today.
No.
So let's go back to reference repository. So sometimes when I've used the reference repository, like I got it set up, I was primarily on a static agent. So, yes, it's a single point of failure. Okay, I'm paying that tax. I get it cloned, it's good, but then sometimes keeping it truly up to date can be challenging.
Well, and that's another management challenge with reference repositories, right? A reference repository is a snapshot in time of the upstream repository. Because it's a snapshot in time, it's useful to avoid copies of the data that existed when the snapshot was created. However, it can't help you with data that's generated after the snapshot was created. So periodically, it's usually a healthy practice to refresh the content of your reference repository on your static agents, on your ephemeral agent images, wherever, so that they are more recent. Now, as a matter of practicality, I see significant benefit even when my reference repository is weeks or months out of date. And the reason I see that benefit is that history is invariant, right? The history that was there is still there, and it avoids copying it. In the degenerate case, in the worst case, all I'm doing is copying all the new content. And if it's a lot of new content, okay, I have to copy a lot. I can reduce that by updating the reference repository to have a more current snapshot than the one that I had originally created.
So, Refspec, reference repositories. What's another thing?
So now there's
It has to be an R, though, because we've already done 2 R's. It has to be a third R.
And I apologize. I don't think I've got an R. I'll have to think about that. Okay, so let's see. Refspecs, reference repositories. We talk about large file. Oh, shallow clone.
Shallow clone.
So
Now that, unlike reference repositories, is a lifesaver.
well, okay. Now I'm gonna. This is a fun one where again you and I get to have disagreement. Shallow clone. GitHub did a study, and they did some benchmarks to look at what the impact of shallow clone was, or what. No, let's say GitHub did a good job of doing a study on performance characteristics of various repositories and various cloning optimizations. And one of the things they found was that there were a number of interesting cases where the choice to use a shallow clone created a very large penalty on the Git controller, on the Git provider server
I don't
side.
care about that. I don't care about that. I care about getting my stuff.
That's a charming thought, except for the time delay while they do that processing.
But
and for me, the answer is shallow clone is an excellent choice to test, to assess, to see does it help. And if it helps, use it. But remember that you need to ask the people who are hosting your Git service for you, especially if it's inside your company, right? Because then you hope they're your friends. Yeah. They're people who you can ask for help and say, I'm about to run this check. I'm about to run this thing, and I want your help to tell me, did I do serious harm to you server side while I was doing this work client side? Because pretty soon I'm going to do 100x that, and you'll hate me if I did something really heavy.
Yeah, sounds like the old days of DBCCs, which could just kill your database. And that's effectively, or a bad analogy. But, I still like shallow clones, but maybe beyond that, one could take us one step further. That's not necessarily that, is -- depth equals 1. One of my favorite flags to throw on anything.
Right, and
how often do I need to go beyond that? There is, but
the depth argument is actually an attribute of shallow clone. So absolutely, that's how the Git plugin implements its shallow clone, is by setting depth.
Oh,
now there is a price to be paid sometimes for the choice to use shallow clone, and you need to be aware that shallow clone really means only give me a certain distance into the history. So I want the current checkout and n before that, the current commit and n before that. And that may have unexpected little surprises on you in your world, where you may say, oh, but I needed to be able to look at the history as part of my job. Or I needed to be able to do something that was related to history. It also can have some interesting behaviors in persistent workspaces. So if you're not using ephemeral agents, but you're using a persistent workspace that on a static agent, that workspace may have, you cloned into it shallow 5 commits ago. You cloned depth 1 with the current. It's therefore got stuff from 5 commits ago and from the current, but missing things in the middle. So don't be surprised when things like that may happen in your workspace. It should be harmless, but you should be aware.
Well, if you're doing that, again, regardless of Jenkins or not, if you did a shallow, then you moved in a different direction, it's time to probably RMRF and just do a fresh clone of whatever your new state is going forward.
Right, and now that's, okay, that you just highlighted for developers one of the benefits of reference repositories. So, okay, now we've been talking about Jenkins controllers and agents, but as a developer, I maintain an intentional copy locally of bare repositories that I can use as reference repositories, because I like the convenience that Darren just described. Sometimes I want to throw my repository away and create a new one. And if I use git clone -- reference, my local, wherever it is, bare repository, I get all the same benefits those CI agents got of not copying the data, and I get a nice fresh copy.
So how am I going to ask this? So you as a developer, how do you keep those bare repositories up to date for you?
I have a little shell script. Okay, it's a Python script. I have a little Python script that I call mirror_git.py. And what it does is it has a list of repositories that it does a git fetch. And it pulls in the bare copy of the latest of each of those remote repositories.
So do you run that? Do you have it croned? Okay, so you run it manually when you want.
Okay, I admit it. My central server that sits at the entry point to my whole network runs that on a cron job daily.
Okay, well, that's what I'm trying to get to, is
right.
Because we've talked about Git is a distributed SCM, but we still treat it like Visual Source Safe or CVS.
Right.
These kinds of things that just, CVS, in theory, you could distribute, but not really. And we still treat it like a centralized repository. It's good to have that, I don't know, how do I say this politely? It's still good to have that single source of truth, right? There is a reference somewhere. Mm-hmm. It's the repo at fill in the blank hosting provider is the one that we are all going to reference. But then when you start, star-crossing everybody, and it's like, well, I could pull from here. I need to cherry pick this commit from Mark. I need to go and grab this PR from. Then unless you're like Linus level, Git foo, you're toast, I think.
And I'm not Linus level, but I certainly like the fact that I can grab things from peers and I can use them. And there's actually, we will likely have a Google Summer of Code project in some future iteration that looks for ways to borrow from repositories that are near the workspace I'm in to get commits from them. And by borrow, the concept would be, hey, I know that markywait/git-plugin is a fork of Jenkins CI/git-plugin. The two are actually quite close to each other. So I can see a case where someday in the future, the Jenkins Git plugin will probably say, hey, I know there's a local copy of this thing that's close. Let's reference it.
That just seems like black magic to me.
And there's an element of it that's dangerous magic, right? Because reference repositories have the other compromise that if you use a reference, you need to keep the base thing around. And so a lot of us like to think that caches are disposable. I can always throw a cache away. And the challenge with a reference repository is it becomes a cache that is referenced from somewhere else. And that means you need to be more careful about when you dispose of that reference repository.
Well, it's in the title. It's a reference repository, not a cached repository.
Right, exactly. Well, but that's
the argument can be made.
Except when mere mortals like Mark Waite make the choice and say, this is just a copy, I'll throw it away. And then my local workspace suddenly starts telling me, oh, you're missing this part and missing this part. Why? Because I deleted them.
Right. Okay. So we did Refspec, reference repositories, shallow clone.
Mm-hmm.
What else?
I think that's about it, actually.
Okay.
We've hit, certainly we'll talk during the session at DevOps World. I'll probably bring more because there's some interesting complexities with regard to how do I do this on Windows? How do I do where the file
Why do
system,
it on Windows? Why do it on Windows?
Other than the fact
James,
that
if you're watching.
A lot of game development happens on Windows.
That is true. That is true.
An awful lot of game development happens on Windows. And with a lot of game development on Windows, they may have real needs for, it would benefit them a bunch if they could use a reference repository consistently and cleanly.
Well, and this is where providers like Perforce and like in the gaming industry, Perforce and what's the other one I'm looking for? It begins with a C. I'm drawing a blank. There's another big one that's used in the gaming industry.
Right.
That because those types of SCMs handle large files just amazingly good.
Right.
I don't know why I'm drawing a blank on the other name, but anyway, I don't think it was even Perforce. It was something else. But anyway,
Perforce was a big positive for me, and I know it's used in the gaming industry. So you're certainly correct there.
Okay. So you're going to be doing a talk around this at DevOps World.
I am.
Funny you should say that. Let's see if this will actually work. So if you're wanting to come to DevOps World, it's September 27th, 28th, and 29th in beautiful Orlando, Florida, assuming there's no hurricanes. It's September. Anything can happen in Florida. But if you want to go, there's a code. In fact, you can go out to devopsworld.com and you can sign up. You can click on register now. I'm on the wrong screen. The conference pass is $13.50. But if you look in the footer or the description of Help Me, you're going to see a code here. DW22 Jenkins RTE. Please correct me if I'm wrong. That is correct. And that will drop the registration to $950. It's on site at the Orlando World Center Marriott, which is near the parks. Just all of them, all the parks. 27th, 28th, and 29th. By the way, September 29th, there is a possibility. I told Mark about this before we started, and he seemed excited. There is a possibility of a Crew 5 launch on the 29th. Don't know when, still too early, but still. From Orlando out to the Cape is not that far.
Well, and I suspect you'll be able to see the rocket going up from Orlando eventually, right? I mean, a rocket going up is a big visible thing.
From where the hotel is, yes, you would be able to if I have all my bearings right. So just in case nothing else, and there's a resort fee that you pay that also gets you a free bucket of golf balls, and you can use some clubs. So, and there's a few other things that the resort fee gets you because it's on the property. It's considered a resort, and all the things that go along with that. Free bus shuttles, all those kinds of things. So, if you can join us, we'd love to see you there. But again, if there's a launch, that could be cool. That's all I'm saying. Get some DevOps and get some space. It doesn't get any better than that. So, with that in mind, what else do we have? Do we have any other items around this?
Well, so I think we ought to talk Hacktoberfest a little bit. I'd like to. I don't have anything else on DevOps World.
DevOps World. But did you have anything else on Git? So this is
no.
Consider that the ad in the middle. No, okay, so you're good. So
exactly.
Anyway, let's wrap up the Git thing. So a couple other things we threw out there in the middle. If you see that you're in an organization that has large files stuck in there and ignoring ripping out the history and maybe cleaning up, creating a new repo, all those kinds of things, Git LFS for large files, or better yet, come up with a way to put it into a binary repository of some way, shape, or form. Whether that's a quote-unquote built for, whether that's Artifactory Nexus, or if you're just going to use something like S3, just plain old disk and stuffing the file out there and referencing it, all those things. Do that for your large files if at all possible.
Right.
And try to not put it in there. And then let's say, but have you ever done Git LFS with S3?
I have not used S3. I've certainly used Git LFS a lot.
Yeah.
I really like it. I'm deeply addicted to it.
So, again, we might revisit Git LFS in a different scenario and show some demos around that, because that could be, if we can get people away from binaries in Git, of any, you said about Jenkins IO, the website itself is 150 meg, I think you said, with all the history over time. How far back does that repo go? Do you remember?
I think it's like 10 years.
About 10 years.
A nice history, but really it hints that if you're not careful, even something as simple as a website can become bloated, right?
Correct.
Even it's just a website, and yet just a website, it's got a lot of content out there because, hey, I wanted to share a pretty picture, or I wanted to embed a large PDF, or I wanted to, etc.
It can cause problems over time. It's nice and convenient, git add. But anytime you do a git add and it's a binary, you should probably stop yourself. And that's probably where a prehook could come in. Check to see if it's a binary versus text. I mean, there's a lot of other things too. Boy, that's another thing we could talk about is pre and post hooks.
Yeah, actually that'd be a fun topic, because I'm really been pleased with my post hooks that I use to trigger builds when I commit. Now, admittedly, it's a poor person's technique, right? Webhooks are much more popular and much more transparent, but post hooks work.
Yes, they do. Subversion, that was a wonderful thing. Except for how you had to manage it, which was not so great, but it worked. It worked. Let's talk about Hacktoberfest, and then we'll talk about one more thing. We'll talk about next week. So, Hacktoberfest.
Yeah, so Hacktoberfest is coming October 1. Hacktoberfest is an event sponsored by DigitalOcean that inspires and encourages people to contribute to open source. What they'll typically offer is some prize, some reward, if you'll submit 5 verified pull requests to one or more open source projects. And the Jenkins project has lots of opportunities where you can help with Hacktoberfest. We've got documentation to be converted from the wiki to GitHub repositories. We've got automated tests that could be added. We've got all sorts of places. We've got documentation to be written, all sorts of things where you can help by contributing in Hacktoberfest.
And again, starting October 1st, the Jenkins project is fully participating. And I believe, is Jean-Marc the one sort of heading it up this year, at least from our side? Okay.
So the Jenkins Advocacy and Outreach Special Interest Group will take the lead, and Jean-Marc Mason is one of the key leaders there. Jean-Marc is also a Google Summer of Code organization admin. We're looking forward to one or more Jenkins online meetups to launch the event. Then we may have sessions during the month of October to highlight different techniques and different ways that people can contribute. We look forward to lots of people joining to help out during Hacktoberfest.
And as we get closer to it, we'll be talking about it more. Now, next week, next Tuesday, August 30th at noon Eastern, 9 a.m. Pacific, and whatever other else time zone you want to be in. We're going to be talking about what's coming up in Jenkins LTS 2.361.1. The release candidate for that is scheduled to come out tomorrow. We were going to talk about it today, but we figured, let's push it out a week. That way we'll have the RC and actually see it in closer to real life. Again, the RC is the NRC. It's not final. But it's better than just the 361 weekly.
Correct.
In theory, because I haven't seen backports. I'm assuming there's a lot of backporting going on.
It's pretty much a typical volume, so it's not an exceptional volume of backports, but there are definitely backports, and we're very grateful to the community who's been exploring with weekly, because we can use what they've learned and we've applied it as backports to 361.1.
Okay, so again, this time next Tuesday, just to get you ready. But again, we cannot talk about 361 without saying one more thing. Java 8 is dead. End of story, right. All over.
That's right.
You need Java 11 or Java 17.
Right. Java 8 support ended in weekly about 6 or 8 weeks ago. Java 8 support will end in long-term support September 7th.
Assuming dates don't slide. Those are the currently published dates, and
correct.
Doing all the normal project management type stuff. Never promise dates except when you say the dates.
Yeah.
Anything can happen, but usually the Jenkins project is pretty darn good about hitting the dates as published way out, by the way, just in case you haven't looked at the calendar. By the way, if you never looked at the calendars, just go out to jenkins.io and you can subscribe to the calendars, the Google calendars, and they will remind you about all of these things that are going on. And in fact, we probably need to get next week's session added to some calendar, maybe the advocacy calendar, maybe.
Sure. Yeah, good idea.
Once I actually schedule it, which we haven't done yet. Details, right? You got to have it before. Never mind. All right. So for everybody that was with us live today, thanks for hanging out. If you're watching the replay and made it all the way to the end, thanks so much. And if you haven't subscribed to CloudBees TV yet, go ahead and click on the subscribe button. Anytime we have new content, which is quite a bit, you'll be notified automatically through YouTube. So thanks, everybody. Have a great rest of your day, and we will see you again next. Do we have anything else between now and then? I think just next Tuesday. I think that's it. And we will talk to everybody about... Well, let's do that again. And we're live, and I can still say that. Everybody have a great week, and we'll talk to you next week. And guess what? I still can't find these videos. It's so many buttons. Bye.